So this video is still on the I do, you do that we've been working on. On the first day in the first video, I went through 1A and B, 2B and then A, because that was the order that we did it. On the second video, which was for block number 1, I went over 3A and 3B in that video, and 4A and 4B. Today I'm going to go through 5A and B, and then 6 and 7. So on this first one, before I get started on this problem, I want to make sure that we understand the following, okay? This is going back to integrated 1. And the problem I'm just going to write is, let's say we have 3 to the x is equal to 3 to the 5th. If I asked you guys to solve this, hopefully you guys would say, oh, x has to be 5. Because if I have 3 to a power equal 3 to another power, the powers must be equal. If I was to complicate this a little bit more, and let's say this exponent I changed to an x plus 3, for example, then what has to be true again is that if this 3 is being raised to the power of 5 and this 3 is being raised to the x plus 3, what has to be true is that this x plus 5 has to be the same as 5. I'm sorry, the x plus 3 has to be the same as 5. And I would take x plus 3, set it equal to 5, and solve. I'm not canceling out the 3's on the bottom for the bases. I'm not dividing by 3. All I'm doing is looking at this and going, hey, the powers must be the same, and I set them equal and I solve. Now, if we have a problem like this, let's say it's 3 to the x plus 3 is equal to 27 to the x minus 1. What I need to do is I cannot just set those exponents equal until I get the bases to be the same. I cannot make the 3 bigger, because what I'd have to do is maybe cube it to get a 27, but if I had to cube this side, I'd have to also cube that side. I don't want to make the 27 even bigger. So can I rewrite this 27 as 3 to a power, because this side is 3 to a power? And so a 3 to the 3rd is equal to a 27. So I could keep this side as 3 to the x plus 3 equal, and my 27, which is being raised to the x minus 1, the 27 can be rewritten as a 3 to the 3rd. Then when I have power to power, what I do when I have power to power is I multiply those. So I would have 3 to the x plus 3 is equal to 3 to the 3x minus 3. And then I would take those exponents, I would set them equal to each other and solve. So I would, for example, minus x, I would add 3, I would divide by 2, and I get x equal 3 as an answer. That is the idea that we need to think about for this problem. Now, this problem is a little bit more complicated, so let me just undo this. So the problem that we're doing is 3 to the 3x minus 1 quantity squared is equal to 27 to the 3x minus 1. So the first thing I notice is I have a 3x minus 1 and a 3x minus 1. So I'm going to let u equal 3x minus 1. So I'm going to have 3 and then u squared. And then on the other side, I'm going to have 27 to the u. Now my goal is to get the bases to be the same. I want my 3 and my 27 to be the same base. So just like the problem I just showed you a second ago, I am going to rewrite a 3 to the 3rd in place of my 27. So the left side is going to stay 3 to the u squared. The right side, which is a 27 to the power u, I'm going to rewrite that 27 as a 3 cubed. And then I get 3 to the u squared is equal to 3, and power to power I multiply, and I get a 3u. So once I get my exponents, my base is the same, both 3 to a power. Now I know my powers have to be equal. So I'm going to say, okay, that means u squared has to equal 3u. This is a quadratic. I'm going to solve this by getting everything on one side and 0 on the other. So I am going to basically minus 3u from both sides. At this point, I'm going to factor out a u from both terms. And then I'm going to set each of these to 0. So when I do, this is going to be u equals 0. This one's going to be u equals 3. Now, we want to remember that u was not in my problem. And I did not have a u. U was representing 3x minus 1. So I am going to rewrite these problems. This one I'm going to rewrite as 3x minus 1 equals 0. And this one I'm going to rewrite as 3x minus 1 equals 3, and then we solve. So in my blue equation, I'm going to get 3x is equal to 1. So I get x is equal to 1/3. In my orange equation, I'm going to add 1. I get 3x is equal to 4. I'm going to divide by 3, and I get x is equal to 4/3. And those are my two answers. So now let's take a look at B. So 5B, similar idea to the other problem. This one, if you haven't paused the video, you might want to pause it and try the problem first and then come back, okay? Because we did this one at the first one we did as a class, this one they did on their own, and then we talked about it. So for this one, what I notice is that I'm going to let u equal 2x minus 5 because both of these have a 2x minus 5. So I'm going to rewrite this as 2u cubed is equal to 16u. And just like the last problem, my goal is to get this base and this base to be the same. I cannot make 2 bigger. I can make 16 smaller. 2 to the 4th is the same as 16. So I am going to have 2u cubed is equal to, instead of 16 to the power u, I'm going to go 2 to the 4th to the power u. And power to power, I'm going to multiply. So I'm going to have 2u cubed is equal to, so 2 to the u cubed, I apologize, is equal to 2 to the 4u. And now that the bases are the same, we can set the exponents equal to each other. So I am going to be working out u cubed is equal to 4u. I'm going to get everything on one side, 0 on the other. So I'm going to get u cubed minus 4u equals 0. I'm going to factor u from both of these, and I get a u squared minus 4u equals 0. There's 2 ways to solve this. One way, some of us might notice that the u squared minus 4 is a difference of 2 squares. It's a u plus 2 and a u minus 2. And get u equals 0, u equal negative 2, and u equal 2. Now, others of us might instead take the 2 factors, set them equal to 0, and solve. So I get u equals 0 just like the other one. Here, I can add 4 to both sides. Then I'm going to square root both sides. Now this is where it gets tricky. Remember, when you square it, you always get a positive and a negative. Just like here, I got a positive and a negative, okay? Now, my answer is going to be an x, so I need to remember that u was equal to 2x minus 5. So I'm going to go 2x minus 5 equals 0. I'm going to do 2x minus 5 equals a positive 2. And I'm going to do 2x minus 5 equals a negative 2. So this is going to be 2x is equal to 5. X is equal to 5 halves. This one's going to be 2x is equal to 7. X is equal to 7 halves. This is going to be 2x is equal to 3. X is equal to 3 halves. And those are our three answers. 5 halves, 7 halves, 3 halves. Now, on the last questions, I did this with the class. So on the last one, we are going to be rewriting, just like we've been doing with most of these problems here. So on number 6, what we want to notice is that this square root of x, if I can take that and square it, and I get, when I square root the square root of x, I get x, it's the same as this, then it's quadratic in nature. And so I am going to let u equal the square root of x, which means u squared is actually going to be x. So I'm going to rewrite this as 2u squared minus 5u plus 3 equals 0. I am going to factor. I'm going to do a box to diamond. I am going to be putting my 2u squared and my 3, so that's going to give me a 6u squared and a negative 5u. I am going to get a negative 3u and a negative 2u, so a negative 3u and a negative 2u. And when I'm finding the outside, I am going to get 2u and u. This is going to be a minus 1, and this is going to be a minus 3. So I'm going to get 2u minus 3 times u minus 1 equals 0. I'm going to set those to 0 and solve. So this is going to be u is equal to 3 halves. This is going to be u is equal to 1. Now, again, remember, we didn't have a u. It was the square root of x. So in place of this and in place of this, I'm going to write the square root of x equals 3 halves. And the square root of x equals 1. Now, in this situation, I don't have a negative, but whenever you have a square root, you want to check to see if this number here is negative or positive. If it's negative, no solution, because we want the principal root, which is the positive root. In this case, it is positive in both cases, so I am going to square both sides. So I'm going to square this side and I get x. I'm going to square this side and I get 9/4. So that's going to be one answer. Here I'm going to square this and I get x. And then when I square my 1, I get 1. And those are my two answers. On number 7. I'm going to do a similar thing. I'm looking here. And if I can take that and square it, and when I do power to power, I get x to the negative second, and I get that, then it's quadratic in nature. So I am going to let u equal x to the negative first, which means u squared is going to be x to the negative second. So I'm going to rewrite this as u squared plus 10x plus 9 equals 0. Sorry, 9u. I'm going to factor that. What multiplies to 9 and adds to 10, and that's going to be a 1 and a 9. So I'm going to get a u plus 1 and a u plus 9 equals 0. So I'm going to get a -1 as an answer, and I'm going to get a -9 as an answer. Now, remember, my answer was not having a u in it. It was an x to the negative first, so I'm going to take this and I'm going to set it equal to x to the negative first is equal to a -1, and x to the negative first is equal to a -9. Now, what I am going to do is I am going to raise both sides to a power that when I do power to power, I get a 1. So I'm going to raise it to a -1. I'm going to raise this to a -1. I'll just put my equal here. I'm going to do the same on the other side. I'm going to raise this to a -1. I'm going to raise this to a -1. So this is going to give me x. And when I have a -1 raised to negative first, what that means is I'm going to take that -1 and move it to the denominator. So I get 1 over -1, which is -1. Okay, so that was me working out this portion right here. I got this. And when I work out this portion here, I'm going to get x is equal to, again, a -9 raised to -1. And so that's going to be 1 over -9, or a -1/9. And that is going to be my other answer. And then we're adding this into our composition book as notes.